because I want to catch whatever you do on tape. What do you think? So I can teach you. All right, anyway. What we are going to do is talk about the notes first, and we're going to go through each of the blanks, and after we fill in the blanks from the notes, we're going to do some sample problems. So the first thing that we want to do is find the vertex. We are talking about a quadratic equation. A quadratic equation, when graphed, looks like this. This is what the graph will look like. It'll look like a U. Now the vertex of the graph is found at the bottom, or if the graph goes upside down, it's found at the top. It's the tip of the U. Okay? Now the way to find the vertex of a quadratic equation, and this is the technical thing, is say negative b divided by 2 times a, where a and b are the numbers in the quadratic equation. A quadratic equation looks like this: ax squared plus bx plus c. This is the standard form of a quadratic equation. So we'd say a negative version of whatever that number is.
Right there, it's
negative b divided by 2a. So we'd say a negative version of whatever this number is divided by twice whatever that number is. And that'll tell me where the x value of the vertex is. We want to plug that number into the equation. After we have found that, there is something that is called an axis of symmetry. An axis of symmetry that goes through that point. An axis of symmetry is a line that whenever you reflect across that line, it's the same on either side. So you can see that the left side of this line reflected across the dotted line would get me the right side. That is the axis of symmetry. All these quadratic equations are symmetrical through the vertex. Then we want to pick 2 x values that are on either side of the vertex. So we have to say pick an x value on the left side, and we want to reflect those points over to the other side. So what we're going to do is we pick 2 x values, and we want to plug in the x values. Then we want to plot these points, and then we want to reflect these points. It's a lot of steps, but none of them are particularly difficult. There will be 3 sets of calculation that we're going to have to do. Okay? But after we do the steps of calculation, it's really just taking points, plotting them on a graph, and reflecting. That's the most difficult steps of these. Does anybody need the blanks still, or can I go on?
No, you can go ahead with it.
I see one person writing down blanks still, so I'm going to let
2 and then you plug it.
All right. Yes, there are going to be 3 plugins for this. So, whenever we are looking at the first problem, the first thing that we wanted to do was calculate negative b divided by 2a. What is a negative version of b? Negative 6 divided by 2 times, what is a? 2 times 1. Can somebody tell me what that is? Negative 3. All right, this is the x value of the vertex. Okay? So this is the vertex. What we are going to do with this is plug it in. We need to plug in 3 x values. So what you can do, sometimes it will help you, is to draw yourself a table. X and y. The first x value that we're going to plug in is negative 3. We need to calculate out what this is going to be. Okay? So negative 3 will go in for x. So when we say x is equal to negative 3, I'm going to write down the work down here. We would say y equals 1. What is x? Negative 3 squared plus 6 times negative 3 plus 13.
I think it's 4. Get it in my head, but I don't know.
I don't think so.
You think it's 4? Okay.
That's what I'm thinking.
Not
You could type all of this into the calculator. Okay, you can type it all out. 1 parentheses negative 3 squared plus 6 parentheses negative 3 plus 13. You could type that all into your calculator and it'll calculate it all for you. So you don't have to worry about order of operations or anything like that with most calculators. So now what this actually is 9 minus 18, which is negative 9, plus 13, which is indeed 4.
I couldn't plug it
Okay.
into this one, could I? Plug it into this one?
So when I say, yeah, you can plug it into that. When you say negative 3 goes in, positive 4 comes out. This is one of the points. The important point is the vertex. Negative 3, positive 4. So this is the vertex right here. That's what we just calculated. This is like the center of your graph. That's the most important point. You calculate the location of the vertex, you get it in the right spot, and then you can have an axis. Now there are points to the left and to the right of this that are very close. Can somebody name me a point that is to the left or to the right of here? We were at negative 3. Do you want to go to the negative 2, the negative 1, or do you want to go to the 4 and the 5?
Let's go with like -1 and -2.
All right, negative 1 and negative 2. So we're going to pick two new x values.
Those are the easiest ones.
All right, yeah, those are the easiest ones. These two x values are to the right of the vertex. You don't have to label these if you don't want to, but it's to the right of the vertex. We have two new points. We're going to have to plug in two new points and calculate out where the y values are at that time. So you're going to have to do several sets of calculations. Which one do you want to do first, the 2 or the 1?
2.
All right, so x equals negative 2 is the next set of calculations that I'm going to do. Y equals 1 times negative 2 squared plus 6 times negative 2 plus 13. And we calculate. So you can type all of that again into your calculator. When I plug it all into my calculator, this is 4 minus 12 is negative 8, plus 13 is 5. Should be 5. Let me see your calculator. Okay, you want to make sure you put the negative 1 in parentheses. Negative 1 in parentheses squared. If you are plugging in a negative number, make sure that you're using parentheses around the values like I have written. Now that'll get me a new point. Negative 2, positive 5 is right here. I am then going to calculate out a third point. Our other x value that we're going to use is negative 1. X equals negative 1. We'd say y is equal to 1 times negative 1 squared plus 6 times negative 1 plus 13. It's the same type of idea as what we just did. We plug in negative 1 for x into both of the locations, and we calculate out again. So 1 times negative 1 squared is positive 1, minus 6 is negative 5, plus 13, I believe, is 8. Okay? So we plugged in negative 1, and we got out 8. Negative 1, positive 8 is a third point on this graph. Normally, I would make you continue plugging in the left side of the graph as well. Plugging in negative 4, plugging in negative 5. But since we already know that this is an axis of symmetry, what we can do is reflect. So this point is right here, 1 away from the line. I'm going to go 1 away from the line on the other side. This point at negative 1, 8 is 2 away. So I'm going to go 2 away. And this is the graph of the quadratic equation. It's much more difficult than graphing a linear equation, is it not?
Oh, it is.
It is. It requires some calculations. No, there's no Chinese method for this. We're going to do another one. Okay? It's not really that difficult once you've plugged in everything. If you've plugged it in a couple times, it's really kind of easy. The starting step. when we look at the equation, here is A, here is B, here is C. The vertex is found at negative B divided by 2 times A. What is a negative version of B? Negative 6 over 2 times, what is A? What is A? 3. What does that calculate out to? Negative 1. Negative 1 is the x value of the vertex. Okay? So I'm going to go ahead and draw myself a little chart, x and y. Negative 1 is going to be one of the points that I plug into this. Okay? So I'm going to go ahead and start that calculation. X equals negative 1. And we're going to calculate out what the y value is at that given place. Y is equal to 3 times negative 1 squared plus 6 times negative 1 plus 5. And we're going to see what that is. So in our calculators, we're going to type it all out exactly as I wrote it, with the parentheses and everything. The parentheses are important. What? Okay, you say 2, you say 14. I'm going to go with 2 on this one, because this is 1 times 3 is 3, minus 6 is negative 3, plus 5 is 2. So, you do see what you did wrong? Okay, good. So I put in negative 1, and I get out 2. I'm going to plot that point, negative 1, 2. This is my vertex right here. You know that through the vertex you have an axis. The axis of symmetry goes through the vertex. It's going straight up and down through the negative 1 there. This is going to be the reflection line. Okay? I need to pick x values, 2 x values. Do you want them to be 0 and 1, or do you want them to be negative 2 and negative 3? What? 0 and 1? All right, so I'm going to try 0, and I'm going to try 1. And once I have those 2 x values, I'm going to reflect them. Okay? 0, by the way, is always the easiest point to plug in. 0 is great to plug in. If you can plug it in, if it's close enough, plug in 0. Because let's see what happens when I do that. 3 times 0 squared plus 6 times 0 plus 5. What is 3 times 0? What is 6 times 0? Plus 5 is... Isn't it really easy to plug in 0? Yeah, that's really easy. So 0 will get me a point at 5. Over 0, up 5. Here's another point that is on my line, on my curve here. And now we're going to plug in the next point. X is equal to 1 comes next. This is the last point that I'll need to plug in. From here I'll be able to reflect. Y is equal to 3 times 1 squared plus 6 times 1 plus 5 equals. I'm going to guess this is your 14 that you got earlier. I'm just guessing. 3 times 1 is 3, plus 6 is 9, plus 5 is 14. So when I plugged in 1, I get out 14. Okay? Over at 1, up to 14, way the heck up there. And now what I can do is reflect these points. Where is the blue point going to go at 0, 5? Where is it going to be? Where will it be after I reflect it across the line?
Sir, can I get you that?
Answer my question. Where's this point going to go?
It's probably going to go 1 over to the left.
So right here on the line?
I mean, no.
1 over to the left from the line.
Yeah, that's what I meant. Like,
All right, where would this point go? At positive 1, 14. It's going to go to, then 2 more. And that would be at negative 3, 14. And this would be my curve. It goes through those points down to the tip, and back up again. It's a very tall, skinny U. Any questions about that? Number 4? That's fine. I'll get to it in just a second. Does anybody have any problems with this graph? I am going to do the next 2 with you, so don't worry about them. All right. First thing we want to find is the vertex. Negative b over 2a. A, b, c. What is the negative version of b? Negative 2 over 2 times negative 1/2, right? Yep. Is equal to. What is 2 times negative 1/2 in the first place?
I got something here.
That's negative 1.
Negative 1.
And then negative 2 divided by negative 1 is positive 2. This is the x value of the vertex. So in my table, I'm going to pick 2. Whoops, I wrote in the wrong spot. In my table, I'm going to pick one of my points to be at 2. I will need to use this point to calculate out where the vertex actually is. Negative 1/2 times 2 squared plus 2 times 2 minus 1. So this is equal to 2, right? Now, what did you say? 2.875? That doesn't seem quite right.
No, it's 1.
2 squared is 4,
It's 1.
times negative 1/2 is negative 2, plus 4 is positive 2, minus 1 is equal to 1, what Isaiah said. All right, so let me check your calculation real quick. Do you still have that? 1/2 times 2 squared, you multiply 4 times 2. Negative 1/2 times 2 squared plus 4. Okay. Whenever you do this, instead of using negative 1/2 as a fraction, do a negative 0.5 times 2 squared. C squared plus 4 get you 1. The calculator can sometimes screw that up. Instead of using negative 1/2 in the calculator as this times 2 squared, don't do it like that. Either put parentheses around the negative 1/2, which is fine, or convert negative 1/2 to 0.5. Sometimes the calculator can screw that up. It thinks it's putting the 2 on the bottom of the fraction when it should be on the top. So either use parentheses like so, or put it as negative 0.5. You'll get the answer right. So positive 2 will get you out a positive 1. I need 2 x values that are close to that. Do you want to use 3 and 4 or 0 and 1? All right, so 1 and 0 are the other x values that we're going to pick. Which one do you want to do first, 1 or 0? 1? X is equal to 1 comes next. Negative 1/2 times 1 squared plus 2 times 1 minus 1 is equal to. 2 times 1 is 2, minus 1 is 1, minus 1/2 should be 0.5, I believe. Is 0.5 correct for that?
Yes.
Okay, good. Then we want to plug in 0. Again, 0 is always the easiest one to plug in, because whenever you plug in 0, it makes a lot of the stuff just sort of not matter anymore. Negative 1/2 times 0 is 0. 2 times 0 is 0. Minus 1 is negative 1. So it makes it a whole lot easier. So whenever I go to graph this, I will have positive 1, 0.5, and I will have 0, negative 1. You can see that it's almost straight, but it is curved a little bit. These points would, of course, reflect across the the axis of symmetry, and you'll get these 2 points over here, the ones in black. And then you can kind of connect the dots with the U shape. Any questions? This is a lot of work in the calculator. It's a lot of work writing it out. Sometimes you can skip a little bit of the work showing it, but you do have to do the 3 calculations. So that is a little bit of a difficulty. Are there any questions about what you're doing? Do you want me to do number 4? Or do you think you have the idea of it? 4 or not 4?
Do
You want me to do 5 instead?
No,
I could just talking about right
Or
now.
do number 5 or not do number 5? Do number 5. It's really the same process every time. Is this probably even different than the last one? Yeah, it is. Okay, so negative b over 2a is how you start it off. What is a negative version of the b number? Positive 2 over 2 times, what's a? Equals. 2 times a half is 1. 2 over top of 1 is 2. Or, yeah, 2. So that is the x value that we're going to initially do. 2. If you want to right now, you could actually pick your other y values. What are close to 2? You can pick your x values of 2, 1, and 0 because they're all close to 2. 2 is my vertex, and then 1 and 0 are close to that.
1 and 0.
Right? 1 and 0 makes sense? So now I'm just going to test my 3 points. X is equal to 2, x is equal to 1, and x is equal to 0. We're going to do all 3 points. We're going to write out the calculation. You can type out the calculation in your calculator and then get the y value. So for the 2 one, that's the one we're going to do first. Y is equal to 1/2 times 2 squared minus 2 times 2 plus 1. 2 squared is 4, half of 4 is 2, minus 4 is negative 2, plus 1 is negative 1. So I plug in 2, I get out negative 1. This is where my axis of symmetry goes. I know it's going to go through there because that was my vertex. I'm going to do the same process again. I'm going to this time plug in positive 1. Y equals 1/2 times 1 squared minus 2 times 1 plus 1. Then we type that out into the calculator, making sure to use the parentheses around the 1/2 if necessary. You can also use it as 0.5. 1 squared is 1, times a half is a half, minus 2 is negative 1.5, plus 1 is negative 0.5. Negative 0.5 is here. After we have done that, we're going to do x equals 0. Y equals 1/2 times 0 squared minus 2 times 0 plus 1. What's that going to equal? 1. Because the zeros don't matter, right? Those things essentially cancel out whenever you're doing zeros. So I'm going to have 0. It's going to be up at 1. So I have my 3 dots. What do I do with the 2 that aren't on the line? What do I do with this blue one? It's going to go over to where? It's going to go over to 3. What do I do with the green one? It's going to go over to where? Go over to 4. And this is my graph. Any questions how that works? Okay? It does require that you pay attention to detail. It requires that you're careful with the calculation.